This is a video for AQA Further Pure Mathematics. Vectors, section 5.3, the equation of a line using the vector product. Well, we've met the idea that the vector product A cross B is A, B sine theta and then n hat, where n is a unit vector, or n hat is a unit vector in the direction of A cross B. This means that if A and B are parallel to each other, then we can say that A cross B will be equal to 0 because sine theta is equal to 0. So if we then think about the equation of a line, we know that a line can be written as R is equal to A plus lambda B, where B is a vector in the direction of the line. But we can also see that the vector from A to P is in that direction, and therefore the vector AP crossed with the direction vector B must be equal to 0. And if that is the case, well, the vector AP is vector R minus A, so that cross product with the direction B we can say is equal to 0 vector. So this is now another way of writing the equation of a line. R minus A cross with B is equal to 0. So for example, if we've got the equation of the line given in the form A plus lambda B, then we can immediately see that B is the vector 3, negative 1, 2, and A is vector 1, 3, negative 4. So we can write that as being R minus the vector 1, 3, negative 4, cross product with the vector for B, 3, negative 1, 2, is equal to 0 vector. Here's the equation of a line written in Cartesian form. And remember, we can read off from this quite a lot about the direction vector. The direction vector comes from the values in the denominator. So we can say that B is equal to the vector 4, negative 2, 3. And also, if we put in the values into the top lines which make them equal to 0, that gives us a point on the line. So 1, 0 and negative 3 will be a point on the line, so that we have the vector 1, 0, negative 3 as being our vector for A. Hence we can write the equation as being R minus 1, 0, negative 3 cross product with the vector 4, negative 2, 3 must be equal to 0. So you can see that this gives us an extra way of writing the equation of a line. So there are several different ways that it can be written. One in the form R equals A plus lambda B, that's the point on the line plus lambda times the direction. This new form that we've just found using the cross product, R minus A cross B is equal to 0. And then finally in Cartesian form, where remember that the vector B is B1, B2, B3, so the direction vector B is B1, B2, B3, and then the point on the line is given by A1, A2 and A3. That completes this video on the equation of a line using the vector product, and in the final video of this series we were looking at the area of a triangle using the vector product.